So we're going to take a look at problem number 21, which asks us promptly to look back at problem number 17. So, okay. Eventually we're going to try and find some critical values, but in looking at problem number 17, we're going to test this claim, the claim that P is greater than 0.3. So it's a population proportion is greater than 30%. So that's our claim like this. A claim like this would be part of which hypothesis, the null or alternative? The alternative, right? Because it doesn't include the possibility of equality. So what's that put it in the null hypothesis then? Yeah, P is less than or equal to 0.3. Now, keep in mind that the author would write just simply P equals 0.3. That's fine. Most students find it easier to do this. Now, the form of the hypothesis test, if you do these things out, kind of the classical approach, would be based on this idea, that what tail test you're doing or using is going to come from the alternative hypothesis. So if the alternative hypothesis is that P is less than some value, then it's going to be a left tail test. If it's that P is not equal to some value, it's going to be a two-tail test. Or, and this is really cool, this is the interactive part, you get to play a role. HA, you could have that P is greater than some value, in which case it's going to be a right tail test. And what's going to happen, regardless of what tail test it is, you're going to take and find the values that put a certain percentage of the area in these tails. And that percentage is our significance level, alpha. So, in our case, we have a right tail test, and we want to put, I think, probably 5% of the area in that tail. We'll find out. Let's see. We need to find the critical values. Use the significance level of 0.05 to decide if we should reject H0 or fail to reject H0. So, okay, let's do that. Let's set up a little test for this. So we're going to have a right tail test, and let's see. We're going to use alpha is 5%. And what that's going to do is it's going to put 5% of the area in the right tail. So this is a Z distribution, which means it's distributed normal with a mean of 0 and a standard deviation of 1. We want to find the point on the Z distribution with 5% of the area in the right tail. So Z sub 0.05 would be the correct notation. That puts 5% in the right tail. How much is in the left tail? 0.95. What value should I put underneath here? 0. Now that tells me something about Z sub 0.05. Z sub 0.05 has to be greater than 0 because this point is to the right of 0. Okay, so it's just a little something to keep in mind as we find our value from StatDisk. From StatDisk, we're going to go to Analysis, and then Probability Distributions. Which distribution do you think we want? Yeah, the normal distribution. All right. Cumulative area from the left. What number should I put in here? 0.95. Right? Because if 5% of the area is in the right tail, then 95% is going to be in the left tail. That's okay. Suppose we made a mistake and just, we're really, really focused. Oh, I'm going to put in 0.05. Let's take a look at what it gives us. It gives me negative 1.64485. How do I know there's a mistake there? Yeah, it's negative, right? It's giving me something to the left of 0, and clearly based on my diagram, I expected something to the right of 0. So, okay, not a big deal. You can do two things to correct it. You can either go back here and say, oops, I meant 0.95, or you can just remember that the Z distribution is symmetric, right? And say, oh, well, all right, I know it gave me negative 1.644, but really I want positive 1.644. So let me go back here. 1.6, I'll round it off, 645. Okay. So this divides up what's called our critical region. If you get a test statistic, so this is something you calculate based on your data. If you get a test statistic to the right here, you're going to reject H0. And anything to the left here, you're going to fail to reject. Fail to reject H0. Now notice we're not saying that we proved that it was true. We're just saying, well, we didn't find enough evidence to convict. That's what we're saying there. Now, if it was a two-tailed test, you would get some similar things. You'd have a reject region on either tail and a fail to reject in the middle. And a left tail test, again, similar. So you're going to have these regions based on your Z distribution. This is the distribution of your test statistic. Now, the form of that test statistic we haven't seen yet, but they gave it to us in problem number 17. They said, okay, the test statistic is 1. You get a Z value of 1. So, okay, well, let's see here. What does that mean? Z value of 1. Well, a 1 would be right here. So what kind of a decision are you making with your test statistic, or based on your test statistic? Are you going to fail to reject or reject the null hypothesis? Fail to reject. So, fail to reject H0. Now, when we get into later sections, we're going to have a whole list of things that we can choose from to help accurately word our conclusion. We don't know exactly what P represents in this case, so it doesn't make sense to go through all this, but there's going to be specific wording for your conclusion from a hypothesis test. And we'll practice this when we get into section 8.2 a little bit more. Does that help? Okay, good deal. There's another problem like that in the homework. You might want to try that one. That's problem number 19. But this is kind of a classical approach to a test, a hypothesis test. Now, there's a different approach that you could take as well, and that's based on what's called the p-value. And that's the approach that I tend to favor because it's just going to be a little bit cleaner for us. We practiced the p-value stuff earlier. Now, for us, the p-value approach amounts to getting a probability of this or something more extreme that is to the right that is less than 0.05. So let's see if we can't figure out what that area is to the right of z equal 1. And let's see. I'll get rid of this. I'll type in a z value of 1. The area to the right of that is 0.15866. Is that less than my critical value or my significance level of 0.05? No. It's not. So if you remember what we said the other day, if the p-value is low, H0 must go. Well, it's not low enough. So the flip side of that is if the p-value is high, H0 will fly. Meaning, okay, we're going to accept H0. It works for us. And that's consistent with what we concluded based on a regular approach to, or a classical approach to our hypothesis test. All right. Good. Excellent question. I'm glad you asked it, and it helped us put to rest a couple questions. So I think a few other people had that. Thank you. Anything else on this? All right. Make sure you take a look at the other problems like this. Problem number 19 would be a good one to practice as well.